Hey guys, it's Mr. C here, and in this video we're going to talk about average rate of change. So the first thing I've got here for you is what rate of change is, and it is the change in the dependent variable divided by the change in the independent variable. And we usually denote that with this little delta. The delta Greek symbol means change in. So we're talking about the change in y over the change in x over a certain portion of a graph or an equation or some kind of a natural phenomenon or something that's going on. So I've got several examples to give you, and this right here gives you a little bit more information to calculate the rate of change formula. You have the change in the y values is the function evaluated at b, the second one, minus the function evaluated at a, the first one, divided by the second one minus the first one. And so we're going to be looking at two places in the function, and we're going to see what the rate of change is over that period of I don't want to say time because it's not always time, but for that span of the domain, we're going to see what the average rate of change is, because sometimes the graphs will go all over the place, and it's really hard to determine, what the rate of change is at any particular place. So we just get an average rate of change over just this big span. So I'll talk about those more when the graphs show up. So I've got some problems that I've selected. And so the first one is a graph. I like to use graphs first because they're more visual. And so in this graph right here, it says to find the average rate of change of f of x, which is this curve. And then it goes down here, well, left to right, it's up, flat, and then starts going up again. That can model a whole different, a bunch of different kinds of things. So we want to find the average rate of change of the function, the graph, from 0 to 10. It's from t is 0 to t is 10. So I know in the previous slide it said x, but that just was the independent variable. So you have independent variable here, dependent variable here, and we want the ratio of the change in these guys divided by the change in these guys over this interval. So from 0 to 10, it starts here and it's going to end right here at 10. And that goes all the way up to that point on the graph. So clearly it changes, the graph changes here and then there, doesn't it? So what we're going to do is we're going to average it out over the whole thing. So what we're going to do is we're going to find f of b, and I'll write this out first, minus f of a over, and let me go ahead and make that look good here, over b minus a. So I'll be using this formula. Okay, so what's f of b? Well, the function evaluated at b, we're going to call this a and that b. B is usually the second one, it's further along. So f of b would be 4. So we have 4 minus f of a would just be 0 because it's here at 0, 0, over all of the, from here to here, all of these for the independent variable. So 10 minus 0, all right, and then we just calculate that. So 4 minus 0 is 4, 10 minus 0 is 10, and then you can simplify that fraction as 2 over 5. Sometimes you want a decimal, and sometimes the fraction is fine. When it's not specified, the fraction is perfectly fine, and so 2/5 would be the average rate of change from A to B. And so as this graph is changing, as it goes along, on average, it's 2 over 5 is going to be the average rate of change all the way through, even though there is a change right here from this slope to this flat, 0 slope right there. All right, let's take a look at this one. So now we're going from 5 to 9, and this is the same graph as the last one. So here is our A, and it goes all the way up to there. And we can even write this down. We can write f of A right there. And then we have B from 9 right here, f of B. And so if we're calculating this, we want this 4 minus this one, also 4, over 9 minus 5. Okay, so we just calculate that. 4 minus 4 is 0. 9 take away 5 is 4. But 0 divided by 4 is equal to 0. And so what that tells me is the average rate of change from here to here is 0. It's not changing at all. And that's definitely true because whenever the graph is flat horizontally, then you have a 0 rate of change. It didn't change at all. So that makes perfect sense. Here we have a different graph. And now we're going from 1 here, so that's our A, all the way up to this point, f of A, to 14 here, that's our B, and then right there would be our f of B. So we want the change in these divided by the change in these. So it goes from 8 here, and then 4 there. So 8 f of B minus the original right here at the very beginning, 4 over 14 minus 1. Okay, that's going to give us 8 take away 4 is 4. 14 minus 1 is 13. And that's not a fraction that's going to look very nice as a repeating decimal. So we'll just leave that one as 4 over 13. Not a problem. All right, let's take a look at this one. Again, same graph, but different span of numbers here for my t values. Okay, so we're going to go from 4. That's my start of A. That would be f of A. Okay, and 10 right here would be my B. And right there is f of B. So this is kind of interesting. It goes down, then it goes up, and then down again, then up again. But from here to here, the average rate of change, if you calculate it, would be f of B, which is 3, minus f of A, which is also 3, over 10 minus 4. So if we calculate this, we're going to get 0 over 6, and the answer is 0. So it turns out that it went up just as much as it went down in this whole span here, as far as an average rate of change. And so even though it went up and then it went down again, it still has a 0 average rate of change over the whole thing. All right, so here we have a graph of the linear function, and it says find the average rate of change from x is 2 to x is 4. All right, so here's where x is 2. That's our A. Right there will be our f of A. 4, 1, 2, 3, 4 will be right here. That's our B, and that is also our f of B. So now let's calculate that. F of B, which is 0, minus f of A, which is 1, over 1, 2, 3, 4, minus 1, 2. That's going to give us, it looks like we're going to get a negative 1 over 2, right? Negative 1/2. Well, to me, that's interesting because this is just a line here. It's a linear function. And I got an average rate of change of negative 1/2. To me, that makes perfect sense because if this line is straight and it has a constant slope through the whole thing, whatever that slope is going to be the average rate of change no matter which values you pick. And you can try it yourself. You can go from here to here. You can go from here to here. You can go from there to there. Any two values you pick for your A and B are going to give you the same exact average rate of change for a linear function. So those are pretty easy to figure out because it turns out that the average rate of change is just simply going to be the slope. Okay, so here we have a parabola, quadratic. And so x is 0 right here. So that's my A. And way up here is my f of A to 2. 1, 2. There's my B. And it's also my f of B. All right, so let's calculate that one. So f of B is 0 minus f of A is 1, 2, 3, 4 over 2 minus 0 for A. That's going to give me a negative 4 over positive 2, and that gives me a negative 2 as my average rate of change from 0 to 2. Okay, this next parabola here, let's concave down. So we're going to go from -3, 1, 2, 3, right there. That's my A, and it's also my f of A. All the way up to 0. That's my B. And here's my f of B. All right, so here's my calculation. F of B, 1, 2, 3, minus f of A, 0, over B, 0, minus A, -3 in parentheses. Okay, so let's calculate. 3 minus 0 is 3. 0 minus -3 is actually going to be a +3. And then we find out that our average rate of change in this graph from -3 to 0 for this function turns out to be 1. Okay, so let's take a look at some functions that aren't linear or quadratic. So this one, we want to find the average rate of change from -2, right here, A, and it's f of A, 3, 1, 2, 3, right here. That's my B, and it's my f of B. And so you might already know what it's going to be looking at it. You've got your f of B, which is 0, minus your f of A, which is 0 also, over 3 minus -2. But have we already figured it out? Well, you're going to get 0 in the numerator, aren't you? This is just going to be a +5. So your average rate of change for this guy from here to here turns out to be 0. So what if they give you a function? If they give you a function, then you're going to have to evaluate that function for both of these. So let's do this. Let's do f of, we need to figure out what f of 5 is, and we need to figure out what f of 1 is. All right, so 5 times -3 is -15, right? Minus 2 would be -17. Okay, 1 times -3 is -3, minus 2 is -5. So I need to figure out what those two are first. So now what I want is this one, the second one, minus the first one, -17, minus -5, divided by 5 minus 1. All right, so let's see what this is going to look like. We're going to get -17, plus 5 over 5 minus 1 is 4, right? Okay, so -17 plus 5 would be -12. Divided by 4, and we see that that's going to be -3. But we already knew it was going to be -3 without doing any work for this one. And why is that? Because it's linear, and the slope is going to be the average rate of change no matter what two numbers we pick for x, the first one and the second one. So that -3 is going to stay constant through the whole thing because that's the slope. So I could have avoided all of this by simply realizing that that was linear, and that slope right there is going to be the average rate of change no matter which two values you pick. And you can try two different ones, but it's going to be -3 no matter which two you pick. All right, let's check out this quadratic here. So let's find out what f of 6 is. And let's find out what f of 0 is. All right, so let's do f of 6. 6 squared is 36. Take away 2 is 34. 0. 0 squared is 0. Minus 2 is -2. All right, so using our formula, we're going to have 34 minus -2 divided by, I'll use a straight edge here to make it look nice, divided by 6 minus 0. All right, so 34 minus -2, I believe that's going to be 36 because two negatives make a positive, divided by 6, and then this one actually turns out to be 6. For your average rate of change. Let's try a quadratic that's a little more complicated. So let's suppose we can't just do this in our head. We need to figure out what f of 1 is, and then we need to figure out what f of -3 is. All right, so what we need to do is plug these numbers in here and here. So f of 1. that would be 1 squared plus 3 times 1 minus 2. 1 squared is 1, plus another 3 is going to be 4, minus 2 should be 2. All right, let's try this one. Negative 3 squared is 9, positive. And then negative 3 times positive 3 is negative 9, minus 2. And what happens now, 9 minus 9 is 0, minus 2 is our result. And so now we have f of 1, which turned out to be 2, minus f of negative 3, which turned out to be negative 2, over 1 minus negative 3. All right, 2 take away negative 2 is 4. 1 take away negative 3 is also 4. And so it turns out for this one that you're going to get an average rate of change of 1. And in our last example, just to show you that this could get more complicated, now we have a cubic function from negative 2 to positive 2. So we need to figure out what f of 2 is, and we need to figure out what f of negative 2 is. That's the first value, last value, and so we need to evaluate that. So 2 cubed is 8, plus 2 squared is 4, plus, plug a 2 in there, you get 2, and then the 1 at the end. All right, 8 and 4 make 12, 13, 14, 15. Okay, now let's do negative 2. Negative 2 cubed is actually going to be negative 8 because you get that extra negative when you cube it. Okay, then negative 2 squared is positive 4, so plus 4. Negative 2 plugged in for that x right there would be a negative 2, and then you got your 1 at the end. Okay, so how's this going to shake out? Negative 8 and 4 make negative 4. Minus another 2 would be negative 6, plus 1 would actually be negative 5. All right, so here's what we got. We got f of 2, which is 15, minus f of negative 2, which is negative 5, divided by, put this here, 2 minus negative 2. 2 minus negative 2. All right. 15 take away negative 5 is actually going to be 15 plus 5, which is 20. 2 take away negative 2 is actually going to be 2 plus 2, which is 4. And this is going to reduce down to 5. All right, guys, so that was a few problems dealing with average rate of change. Hope that helps. You can watch the video as many times as you want to replay some of these. And remember, like and share, subscribe to my channel if you're not already. And we will see you guys later. Bye.